Section 6.4a is about solving compound inequalities, specifically those that contain the word and. A compound inequality is when two inequalities are graphed on the same number line. So you're comparing two inequalities, and when you put them together, it's called a compound. Now, a key word in this section is intersection, and that's the graph of a compound inequality that contains the word and. We call that the intersection. And when you graph that, you take what is in common to both inequalities. Now, all this will make a little more sense when I do an example. Here we go. We have to graph the set of x is less than 3, and then notice the word and at the same time x is greater than or equal to -2. So what are we saying? We're saying we want all the numbers that are smaller than 3 and at the same time are bigger than or equal to -2. There are some numbers that work in this one, but not in this one, and vice versa. So let's show you how to do that. First, you're going to make a graph of the first inequality. Start with a 0. And how do I graph x is less than 3? As we've learned in the past, you put an open circle on 3, and less than goes to the left, so we'll shade to the left. Now below that, on the same graph, I'm going to try to line things up. I'm going to go x is greater than or equal to -2. Because it's greater than or equal to, I'm going to put a closed circle and shade that. And then the last graph is the solution. What you want to do is you want to try to build it using the same points. Here's 3, here's -2. But now you want to combine these. You want to look at these two graphs and say, if I take this graph and I lay it over top of this one, can you see where the two graphs overlap each other? Can you see where they cross? I mean, if I hold it over top like that and then use a different color, you can see that right in here in this box is the area where the two graphs crisscross. Now, you don't have the benefit of technology to do that, so when you do it, you want to try to look at it this way. Where they cross each other will be from there to there, everything in between. That's where they intersect or cross over. So on my final graph, I'm gonna graph that intersection, the combination of those. Open circle here, and I'm gonna shade what's in between. So this is my solution. These are all the numbers that are both less than 3 and at the same time greater than or equal to -2. That's what that shaded area represents. One other thing about and inequalities is this. If you write this answer with a letter x being in between the number -2 and the number 3, well, it would look like this. You would say that -2 is less than or equal to x, and x is less than 3. Notice what I've done. I've taken the solution right there, and I've rewritten it without using the word and, by putting the letter in between the two numbers, the smallest one on the left, the biggest one on the right, and then the symbols that make it correct in between there. And inequalities are the only ones that you can do that with. You can rewrite it without using the word and then you can also pull them apart. That's a special property of the and inequalities. Here's another example of a compound inequality using the word and. Before I solve it, I want to show you again this idea of combining them. Notice they both have w plus 3's. So I could rewrite this as a w plus 3 in the middle, with a 6 and a less than on the left side and an 11 on the right side. So these actually mean the same thing. This is written without the word and this is written with the word and. So be aware that and inequalities can be pulled apart and put together doing that. So over here I'm going to solve these first. I'm going to subtract the 3. So we end up with 3 is less than w. Remember, we want the w on the left, so we switch the sign. Subtract 3, so w is less than 8, and then we have the word and. Now we have an and inequality that we can solve by using 3 graphs. Using technology, I can duplicate those 3 fairly quickly. You're going to have to write them out. So w greater than 3 looks like this. Open circle on 3, greater than means go to the right. W is less than 8, open circle on 8, go to the left. And now we've got to find the intersection where they cross over. So from here to here. But the question is, do we include the 3 and the 8? And the answer is no, because 3 would have to be colored in on both of them for it to be included. So we're going to leave both dots open and shade between. Now, how do we write the solution? We say 3 is less than W. Why W? Because that's the letter I used up here, and that's less than 8. So that's my solution and my graph. Here's a compound inequality. Now, it doesn't have the word and, but we know it's an and because I've told you that and's the only kind that you can write with the expression in the middle and the numbers on the end. So how do we break it up? We take the negative 5 less than x minus 4. We take the entire middle part and pull that out. Then we use the word and then we rewrite the middle all over again. X minus 4, we use it twice, and then less than 2. So that's how we separate it into two inequalities that we now can solve. Add 4. So negative 1 is less than x, rewriting that as x greater than negative 1. Here adding 4, x is less than 6, and that's an and inequality. So how do we graph that? Now, if you're good enough to do this without doing all three graphs, that's fine, but I'm going to do all three for those that are still struggling with it. So here we go. X is greater than negative 1, open circle on negative 1, shading to the right. X is less than 6, open circle on 6, shading to the left because it's less than. Now I've got to find the intersection where they cross, so right in here is where they overlap each other. So my final graph will have open circles on negative 1, negative 6, and the shading will be in between. Writing your final answer, negative 1 is smaller or less than x, which is smaller than 6. Now, if you've been paying attention, you'll notice that almost all of the and inequalities, actually all the ones we've done, have looked like this. Most of them will, but not all of them. The key is looking for where the two graphs intersect or cross over.